In this video, we're going to talk about factoring trinomials of the form x squared plus bx plus c. Notice that these are degree 2 polynomials that are going to have 3 terms. And notice that the leading coefficient here is 1. That's a 1 in front of that x squared that's understood to be there. The way that we factor these things is really going to be coming from our FOIL method or our repeated distributive property when we multiply binomials, all right? And so I'm going to look at these first few examples here. I have an x plus 7 times an x plus 2. If I multiply that together and then I simplify, meaning combine like terms, I'll see that I'm going to get an x squared plus 9x plus 14. Likewise, if I do the x minus 3 times the x minus 5, when I multiply them, I get an x squared minus 8x plus 15. And then last but not least, when I multiply the x minus 7 times the x plus 5 and do all of my simplifying, I'm going to get an x squared minus 2x minus 35. And if you notice, looking at these 3 answers here, they're all of the form x squared plus bx plus c. All right, and I always want you to remember that when we factor polynomials it's the process of rewriting them as a multiplication of 2 or more polynomials. And so if you look at this left-hand side, the things that I started with, these are all a multiplication of polynomials. And so what we're really going to be doing is we're going to be starting on this side, and our final answer is going to be the stuff on that side over there. All right. Now let's figure out how we get that. Notice here. Notice the structure here. There's an x in all of these first spots here. And the reason why that's the case is because when I multiply x by x, I get this x squared sitting here. So the first thing I do when I start to factor these things is I immediately draw 2 sets of parentheses and I automatically put my x's in those first spots, because that's the only way that I'm going to get an x squared in each of these first spots here. Okay. Now the other numbers are going to be coming from here and here for each of these values here. Now let's see how they're related. All right. Notice here I have a 7 and a 2, all right? If I multiply 7 and 2, I get this last number that's sitting here. That comes from the FOIL method. So the stuff that I multiply to get the first spots, which is here and here, give me this leading term. The things that I multiply to get my constant term go into these 2 numbers here. Now, if you notice, 7 and 2 aren't the only 2 numbers that you can multiply to give you 14. You can also use 1 and 14. So why did I use 7 and 2 instead of just 1 and 14? Well, you have to look at this middle term here, right? If I add 7 and 2 together, notice that I get this 9 that's sitting there, all right? And so that's how I get this middle term here. The same thing is going to happen for each of these other cases here. Notice that this -3 and this -5 will give you this positive 15. So that is where this comes from. All right. Again, I can use 1 and 15 to give me positive 15. Or I can use a positive 3 and a positive 5 to give me this 15 right here. All right. Again, the reason why I chose the -3, notice that's a minus sign there, and a -5 is because when I add -3 and -5, I get this -8, which is sitting here. All right. And then the same thing is going to happen here in this last term, right? I need a -35 when I do my multiplication. Of course, this -7 and that positive 5 will give me the -35. Well, why didn't I use let's say a -5 here and a positive 7 here, right? Again, it's because of this middle term. The only factors of 35 that I can write them and multiply them together that'll give me a sum of -2 is to put the negative on the 7 and the positive on the 5, right? And so I get this middle term here. So I always start in this fashion right here, and then I look at my constant term. I want to find 2 numbers that multiply to give me these constant terms, but add up to our linear term or our middle term with x to the first power here. All right. And so if you want to write that out, factoring trinomials of the form x squared plus bx plus c, Notice that I used this term here. It factors into two binomials. Remember, these are considered binomials. They are polynomials with two terms in them. The first thing we do here is we factor out the GCF if possible. In each of these cases, there is no GCF. Each of these cases here, there is no GCF. But there will be examples where there will be GCF. All right, so that's the first thing I want to do. But the most important part, after I factor out the GCF, I'm going to go ahead, do my double sets of parentheses with my X's in my first spots. And then the numbers that I'm going to put in the second spot are the two numbers that multiply to give you C, but add up to B. Now remember, your C, I'm using this form right here, is your constant term, like the 14, 15, and negative 35. And I want to find two numbers that not only multiply to give me C, but add up to B. Notice the B is the number that are the coefficient on the X, 9, negative 8, and negative 2. And those are the numbers you're going to put here with their signs. If it's positive, put a plus. If it's negative, put a minus. And that is how you factor trinomials of this form right here. Let's look at multiple examples of this. All right, in part A, I have x squared plus 13x plus 36. All right, again, the first thing I'm going to look at and see if there's a GCF. In this example, there isn't. And so since there's no GCF, I immediately know that if I'm going to factor this, it's going to factor into two binomials. Since this starts with an x squared, I'm going to put my x's here. And then I want to find two numbers that multiply to give me 36, but add up to 13. All right, and if it takes you doing this, go through the factors of 36. For instance, you can do 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, right? That'll give you a positive 36. You also have to pay attention to signs. You also can do a negative 1 and a negative 36, right? Those will multiply to give you a positive 36. Negative 2 and negative 18. Negative 3 and negative 12. Negative 4 and negative 9. A negative 6 and a positive 6. Those are all the two pairs of numbers that can multiply to give you a positive 36, but you want it to add up to a positive 13. Well, since we wanted to add up to a positive 13, there is no way that two negative numbers are going to add up to a positive 13. So we're not going to be in that case right there, all right? But if I add 1 and 36, I get 37, so I'm not going to use those. 2 plus 18 is 20, so I can't use those. 3 and 12 is 15, so I can't use that pair. 4 and 9, that is 13. So since those are both positive, I'm going to say x plus 4 times x plus 9. And that is my answer in factored form. You can always multiply these things out to see if you get your original equation. I'll let you do that on your own. All right. Let's look at part B. We have x squared minus 14x plus 13. Again, there is no GCF, right? And so what I'm going to immediately do is I'm going to do my double sets of parentheses here, x and x in the first spots. And I want to find two numbers that multiply to give me 13, but add up to a negative 14. Well, if you think about it here, 13 is a prime number. So only 1 and 13 will give you 13. All right. However, we can have some negatives, right? If we want a positive 13, we can also use a negative 1 and a negative 13. And those are all of my possibilities. And so now that I have all of my possibilities, I want to find the pair that add up to the negative 14, which is sitting here. Okay. Well, if I add up 13 and 1, that gives me a positive 13. However, if I do the negative 1 plus a negative 13, I have what I need. So I'm going to use a minus 1 and a minus 13, and there is my solution. Let's look at these other two examples here. X squared plus 3x minus 54. Notice here, I don't have a GCF once again, and so what I'm going to do is I'm going to draw my double set of parentheses here. Since I have my x squared first, x here, x here. I want to find two numbers that multiply to give me negative 54 and add up to a 3x. Notice here that I went through this entire process, these entire processes here, writing out all of the numbers. I want you to get to a point where you don't have to go through that process. You can think of the factors in your head and remember that they have to add up to this b term here. And then once you find those numbers, instead of writing them all out, maybe you can just go ahead and put them here. For instance, two numbers that multiply to give me negative 54, but add up to a 3 would include numbers like a positive 9 and a negative 6. Notice here that 9 times negative 6 is negative 54, and 9 plus a negative 6, and when I add a negative, that's like subtracting 6, I get this 3 right here. And so this is my solution in factored form. All right, part D, we have x squared minus 14x plus 49. Again, there is no GCF, and so what I'm going to do here is I'm going to go ahead, draw my set of parentheses here, put an x in my first spot so that I can get that x squared. Two numbers that multiply to give me 49, once again, multiply to give you 49, but add up to a negative 14. Those two numbers would be negative 7 and negative 7, right? Again, check yourself. Negative 7 times negative 7 is a positive 49, and negative 7 plus negative 7 is a negative 14. All right, we can go one additional step, right? Anytime we have two things that are multiplied together and they're the same thing, we can write it as one quantity squared. And so that can be written as x minus 7 quantity squared. Let's look at a couple more examples dealing with multivariables. All right, these are two examples dealing with multiple variables, and somehow this is supposed to be E, and this is supposed to be F. But in any account, we have two variables. And so this is a little bit more difficult than dealing with factoring when we had only one variable, all right? And the thing is that can get a little confusing is where do we place our variable, all right? Our variable, right? So if I look at this example here, I'm still going to have, it's still a trinomial. There's still a 1 understood to be in front of my leading coefficient, all right, as my leading coefficient. However, and notice here, I still have an x squared, so I know I'm going to start this the same way, but the difference is I have an xy here, and I have a y squared here, all right? I'm going to start with this y squared. Remember, whatever becomes two numbers that multiply, right, that we're going to put in these spots right here, have to multiply to give us this 44y squared, right? And so I know I'm going to have at least a y here and a y here, right? Now that I've gotten rid of the y squared, I've got to find two numbers that multiply to give me the 44, but also add up to the 15, all right? And it'll take care of these x, y's, and this y squared that is sitting here. All right, and so if I think about 44, two numbers that multiply to give me 44, add up to 15, those two numbers will be a positive 4. So I'm going to have this as 4y, that's 4 times y, and a positive 11. Notice that that is written as 11y. So my solution without all the extra stuff is x plus 4y times x plus 11y. And what I'm going to do is I'm going to check myself just to make sure I did that correctly. All right, so x times x will give me x squared. X times 11y, I can write that as 11xy. 4y times x, I can write that as 4xy. And 4y times 11y would be 44y squared. Of course, we have like terms in the middle here, so I'm going to add those together. I get x squared. 11 plus 4 is 15, so I get 15xy. Plus 44y squared. And this is exactly the way I started with, right? So using your knowledge of remembering that, hey, whatever I put in these spots right here, they have to give me this last term from my for method or whatever, then you will be able to place your variables correctly. All right, let's look at part F. This is going to be kind of similar. It still has two variables, so it's a little similar, but it's also a little different. All right. This time I have x squared, y squared, x squared times y squared plus 10xy minus 24. All right. Notice here that your x squared, or both of your variables that are squared, are in your first spots. Notice that there is still a 1 in front of your leading term, And so I'm going to start it very similarly, but this time I can't just put just an x in these first spots, because it's x squared times y squared. I have to have an x times a y. And remember, you don't have to put the multiplication symbol between the x and y. Just write them next to each other because it's understood. And now that I have my variables in this spot here, right, for my first spots to give me my f and my FOIL, all I have to do now is find two numbers that multiply to give me negative 24 and add up to a positive 10. All right, and it'll take care of this xy that's in the middle. So those two numbers that I need to find that multiply to give me a negative 24 but add up to a positive 10 would be a positive 12 and a negative 2. All right, and so my solution would be xy plus 12 times xy minus 2. All right, and again, you can check this to make sure that it is actually correct, but this will be considered your final answer. And this concludes the video on factoring trinomials of the form x squared plus bx plus c.